Hi guys, welcome back to the channel. Today we're going to take a complete look at Kafka. At first we're going to go through some of the basics, and then I'm going to dive deeper into some of the more advanced topics. So the first question is, what is Kafka? Kafka stores data as a stream of continuous records. So let's see what that means. So if you imagine the log file we have to the right, every time there's a new HTTP event that's coming in, it's getting added to the end of the log file. So Kafka is very, very similar. So imagine of it as like a database of records, and every time a new record comes in, it's added to the end of the table. So it's very quick because every time there's like a new data that comes in, you just add it to the end. So for a more practical use case, let's look at some examples where we can use Kafka. So imagine a ride-sharing app like Uber or Lyft. Each ride can be one record in Kafka. So whenever there's a new ride that gets requested, we add it to the end of the list. To the right, you can see we have 3 Kafka records, and each of the record has all the information related to that ride. Similarly, for food ordering app like DoorDash, Uber Eats, or Yelp, each order is one record in Kafka. So whenever there's a new order, you just keep adding it to the end of the Kafka topic. And each record is one order, so it contains all the information related to that order. In this case, you have the ID, the item, the amount, and the currency. So that brings us to the most fundamental concept of Kafka, that's called a Kafka message. A message is the atomic unit for Kafka. So it's the most basic version of anything you can have in Kafka. In the example we had to the left, one message is one record that you can see over here. So each order is one record, which is one message. So similarly, each ride in the Uber example I had before is going to be one message in Kafka. And if we have a logging system, so let's say all your logs are being written to Kafka, then each log entry is going to be one message that we're writing to Kafka. Here are some examples that I have for you. To the left, imagine we have a Kafka topic where we have all the food orders. Each order is going to be one message, and each message is going to have all the details related to that food order. Similarly, to the right, imagine a Kafka topic where we have all the rides that are being requested. As new rides come in, they're going to be appended to the end of the Kafka topic. Each ride is going to be one Kafka message, and each message is going to have the ID, the start, and the destination. So now that we talked about how we can keep on writing to a Kafka topic, so we keep on writing it to the end of the topic, let's see how can we read it. When reading messages from a Kafka topic, Kafka uses something called an offset. Offset makes it very easy to go to whichever message in the topic that you want to read. It starts from offset of 0, so the first message is offset 0, and then the next message, you move the offset by 1, so it's going to be 0 plus 1, 1. The third message is going to be 0 plus 1 plus 1, so you're going to be in offset 2. So similarly, like whenever you want to jump to a given message, you can just use the offset to add to your starting index. The next concept is what we call a Kafka Producer. Anything that publishes a message to a Kafka topic is called a Kafka Producer. So it can be a Python script that you write. You can literally just write to Kafka and you're going to be a producer. You might have a microservice which writes to Kafka whenever a certain endpoint is called. In that case, that endpoint and that microservice in general is a Kafka Producer. It can be a front-end app which directly writes to Kafka. It can even be just your basic command line interface where you run a command and you directly publish a message to Kafka. So essentially anything that writes to a topic is a Kafka Producer. Now let's look at the other end, which is a Kafka Consumer. A Kafka consumer is anything that is reading from a Kafka topic. The key thing to know about consuming Kafka messages is you read messages from a topic in an ordered fashion. So when you're reading the messages, you're going to be reading it in the same order that they were inserted in. So in the example we had of food ordering, let's say we had 10 orders and we inserted them in the correct order. So 0, 1, 2, 3, all the way to 10. When you're reading from that topic, you're going to maintain the order. So you're going to start from 0 and go all the way to 10. This is like one of the most important feature that Kafka provides, the guarantee that you're going to be reading in order. You can have multiple consumers that are consuming from the same topic, and they can do so independently. So let's say you have a topic, just like the one we had, where we had all the food orders. You can have 5 different consumers reading from this topic in an orderly fashion and not affect each other. So they're very independent. We're going to dive deeper into how multiple consumers work in a later slide. As the consumers are reading from Kafka, they use offset to move between messages. So let's say they're going to start from 0 and then add 1 to it, and then add 1 to it, add 1 to it, and keep going forward. Consumers can replay messages at any time from anywhere. So if you want, let's say you only want to read the last 5 orders, so you can just skip the first 5 using the offset. So you can do like 0 plus 5 if you have 10 orders, and then just read 5, 6, 7, 8, 9, and 10. So you can use offset to easily move between messages and read from wherever you want to. Let's say you have a Kafka topic that's been written to for the past 1 year. So you already have like millions of messages in it. And you have a very new consumer and you want to replay all the data that you wrote to this Kafka topic in 1 year. You can literally just tell your consumer to start from offset 0. So this is going to make sure that when your consumer starts, it starts reading from the most early message, and in an orderly fashion, it reads all the way to the end. So it's very, very easy in Kafka to go to different timelines and read messages from wherever you want to start reading from. Here's the most basic architecture that we have of Kafka. This is a very, very simple example, and later on I have more real-life examples that are going to make much more sense. So essentially what Kafka is, you have a producer, which is a Kafka producer. The producer can write messages to a topic. A topic is just a logical unit of similar messages. So you have the producer writing messages to the topic. The topic retains the messages, so you're gonna indefinitely keep the messages. And then you have consumers. The consumers can read from this topic. You can have multiple consumers. In this case, we have 3 consumers, and each of them are independently reading from the topic. So they'll have their own offset, and they're gonna read at their own speed. It does not, they don't need to depend on each other. Let's have a more realistic example. Going back to our ride-sharing example. Let's say you have the ride service, which is the first service that gets hit when a ride is requested. What the service does is it writes a message to a Kafka topic. In this case, the Kafka topic is called ride requested. This topic will contain all the messages of every ride that was ever requested. Now you have this Kafka topic called ride requested, where you'll have all the rides that were ever requested. And you can have consumers on top of that topic. In this case, we have transaction service, driver rider profile, or analytics. Each of them are consuming from this topic independently. So whenever there's a new message that is written to the ride requested topic, each of the consumers will be notified of it, and then they can do some processing. So let's say the transaction service can read from the log And whenever there's a ride requested, it can calculate how much the cost is and then charge the user accordingly. The driver or rider profile can just like add more details to the profile of the riders that requested the ride. And there can be an analytic service that is just every time there's a new ride, it's doing some kind of an analysis. So all these are happening independently, even though they're all dependent on the same Kafka topic. So you have a very easy decoupling situation with Kafka. Similarly, for food ordering, it's the same thing. Whenever there's an order, let's say it hits the order service first, and the service writes a message with all the order data in a Kafka topic called order placed. And then you have different services that are listening to this topic and reading from it. So you have the scheduling service. So whenever there's a food order, this service reads the message from the topic and then schedules it so that it reaches the consumer at the appropriate time. You have the routing service, which can maybe help the delivery person with routing so that it goes to the correct place. And you have the transaction service, which is reading from the same topic. And whenever there's an order, it can take care of the money side of things where they're charging the correct people the correct amounts. So once again, your source of truth is that Kafka topic called order placed, and all these different consumers are independently consuming message from it and doing different kind of processing. So as you saw in the last two examples, you have the producer writing a message to the topic, and then you have all the consumers reading from the topic. So your topic is what is the source of truth. So all the data related to a certain thing is going to be in that topic. So you can rely on that topic to be the one source of truth. Whenever you have a new consumer, let's say in this example, whenever you have a new consumer that needs to go through all the orders that were placed and do some processing, you can just create the consumer and start listening to the topic from an offset of 0. Yep, that's what I have over here for you. So let's say we have the new consumer, which is the blue box at the bottom. If you wanted to start processing from the first message ever written to the topic, you can just tell the consumer to start consuming from an offset of 0. Okay, so that was the first section, which is the fundamentals of Kafka. So we went through, let me just go back. So we went through what Kafka is. We had a few examples of real-life use cases of Kafka. We went through what Kafka Message is. It's the most atomic unit of Kafka. There are a few more examples over here. We went through what Kafka Offset is and how it makes it easy to move between messages. Kafka Producers, it's pretty much anything that's writing to a topic. Consumers are what's reading from the topic in an orderly fashion. And then we went through the basic architecture examples, just giving you an example of how everything fits together. So now we're going to move to the second section, which is going to be scaling Kafka. This is going to be slightly advanced, so if you're still just learning Kafka, I think you can avoid this part. But if not, feel free to just stick by because there are some very helpful things in the coming slides. Okay, so the first concept you need to know about scaling in Kafka is the concept of Kafka partitions. One topic can have multiple partitions, and the data you are writing into the topic is split across the multiple partitions. So think of it as database sharding. So let's say you had a database of all employee IDs. So all the employee data is in one database. If your company gets very, very large, it might not be able to write all employee data in one table. So what you do is you split the table into 4 smaller tables. And let's say depending on the ID of the employee, you write to one of the 4 tables. Partitions is very, very similar. One topic can have multiple partitions. This way your data is split between the partitions so that everything does not depend on one partition only. So let's say you have one topic, and let's say the topic has more than one partition. So the first question is, how do you know which partition to write to? That's where the concept of partition keys come in. So there are multiple ways we can partition. The first one we're going to look at is by partition keys. So you can partition your topic logically. So let's say in this case, our Kafka topic, which is order placed, we have 3 partitions, and we partition the topic by the location the order is coming from. So all Chicago orders are going to partition 1. New York orders are going to 2, and Atlanta orders are going to 3. This way, every time an order is coming from one of those cities, it's going to a different partition. But if you split the partitions like this, your producer or your Kafka producer that's publishing the data will need to know which partition to write to. So it needs to know the location and then write to the appropriate partition. The other concept is partitioning your topic without any logical reasoning behind it. So let's say you just want to partition it so that you can scale faster, so that you have multiple partitions to write to. This way you can have multiple partitions of the same Kafka topic, and when writing to the topic, your producer does not have to know any partition key or anything like it did over here. It just writes to the Kafka topic, and it's the Kafka broker, so like the Kafka software that you're hosting, that decides which partition to write the data to. It can be round robin, so you can configure your Kafka cluster so that it writes to partition 1 first, 2, 3, and then go back to 1, 2, 3. Or it can depend on the load. So let's say you have partition 1, which is being bombarded with requests. So your Kafka cluster can make sure the newer messages are being routed to partition 2. So there's an easy way to load balance. If your topic becomes very, very busy, you can just have multiple partitions. Now that you have multiple partitions for a Kafka topic, ordering becomes an issue. As I mentioned in one of the previous slides, the most important guarantee that Kafka gives you is the order of messages. So if you wrote 200 messages in a certain order in one partition, when you're reading from that partition, you're going to be reading in the same order those 200 messages. However, when your topic has multiple partitions, there's a small thing that changes. Within each partition, the messages are ordered. So let's say if you have 3 partitions, within the partition, the message is going to be written in order, and when consuming, you can consume it in the same order. So it's going to be the earliest at the beginning, and then the next one, and then the next one, all the way to the latest. However, there is no guarantee of order between partitions. So if you have 3 partitions like we have over here, if you're consuming from only one partition, so in this case, let's say partition 1, you have the guarantee that the order you're reading it in is the same order the messages were inserted in. However, if you're reading from 2 partitions, 1 and 2, and let's say you have one message from 1 and then one message from 2, you do not have any guarantee of which message came before, because the order is being maintained only within the partition. Across the partitions, you have no guarantee. So let's look at a few practical examples now of how multiple partitions fits in to how consumers are reading from a Kafka topic. So the first question is, how does one consumer read from multiple partitions? So let's go through the example over here. Let's say we have one consumer. You can say it's called consumer 1, and we have 3 partitions. of our order placed Kafka topic. So our Kafka topic is order placed. The topic has 3 partitions that the data lives in, and then we have one consumer. In this case, your one consumer is just going to be reading from all 3 partitions. It's pretty straightforward. You have one consumer, it needs all the data, so it's just going to read from all 3 partitions. When reading, there are 2 things you have to keep in mind. Within the partition, the data is ordered, but across the partitions, data is not ordered. So if you wanted to consume data in such a way that everything is ordered, you cannot have 3 partitions, because by having 3 partitions, you essentially divide the data into 3 parts. Now, let's say this is taking a very long time because it's only one consumer you have, and by one consumer, I mean, let's say you have one instance of that consumer, and it's consuming from 3 partitions. That's a lot of data, so it's taking a long time. As a result, you want to scale up, and to scale up, you want to have 3 instances of the same consumer. So what do? So a visual representation, you have the same Kafka topic, the same 3 partitions, but now you have 3 instances of the same consumer to make the consuming even quicker. So how do you do that? That's where the concept of consumer groups come in. Consumer groups is a collection of consumers that work together to read messages from the same topic. By default, each consumer will belong to its own consumer group. So let's look at an example to make the concept more tangible. So you have 3 consumers to the right over here. And the way you organize it is all 3 consumers, let's say you explicitly mention that all 3 belongs to the same consumer group, right? And if you do that, now that you have one consumer group with 3 consumers, you can have each of your consumer within that group consume each of the partitions. So you have 3 partitions, and you have 3 consumers in one consumer group. Each of your consumer can consume data from each of the partitions. There are a few rules that you have to be aware of when you are organizing multiple consumers in the same consumer group. One partition cannot be read by multiple consumers in the same group. So in this case, you have 3 consumers in the same group, so you can't have 2 of them reading from the same partition. One of them, each partition can only be read by one consumer in that group. Only one consumer in a group gets to read from a single partition. That's what I just talked about. This is how order is maintained when consuming messages. So this way you know that your instance 1 is only reading from partition 1 and all data within partition 1 is ordered. So you know for sure that everything you're reading from partition 1 is ordered. However, if you had instance 1 and 2 reading from the same partition, at that point you could not really guarantee that within partition 1 you're reading everything in a ordered fashion. So to simplify that, one consumer within a consumer group can only read from one partition. All right, so this is just what we had in the previous slide. When you have 3 partitions, you can have a maximum of 3 consumers. And why is that? Now, if you had a 4th consumer, where is that consumer going to read the data from? It cannot read it from 1, because your instance 1 is already reading from it. It cannot read it from partition 2, because your instance 2 is reading from it. And it cannot read it from partition 3, because instance 3 is reading from it. So your consumer is just going to be sitting idle, not consuming anything. This is just to satisfy the rule in the previous slide, which is one partition can only be read by one consumer within a consumer group. Let's run through another example. Let's say you have 4 partitions and 2 consumers. What happens then? So you have analytic service 1, 2, and you have 1 consumer group, and you have 4 partitions. So in this case, you can just split it. So 2 of the partitions can be read by one of the consumer. The other 2 partitions can be read by the other consumer. This still satisfies the rule we had, where one partition is not read by more than one consumer. So yeah, each gets their own partition, and there is no partition sharing between the instances. Now, this is a very common use case. I'll just run through the use case. So I have different microservices or programs that scale independently and consume independently from the same topic. How does that work? Okay, so let's say you have 2 consumer groups now, right? Imagine a consumer group as a microservice or a program. The first consumer group, let's call it the analytics service, has 2 running instances. The other consumer group, let's call it the transaction service, has 1 running instance. So remember the rule, within a consumer group, 1 partition can only be read by 1 consumer. Because of that, the analytics service, which has 2 instances, can read independently from partition 1 and 2. So instance 1 is reading from partition 1, instance 2 is reading from partition 2. But transaction service, which has just 1 consumer in that group, it can just read from partition 1 and 2. So it can just read from both because there is only 1. If you scaled up transaction service and added another instance to it, what would happen is one instance would read from partition 1, the other would read from partition 2. If you had 3 consumers in any of the consumer groups, the third consumer in those groups would be sitting idle because there are only 2 partitions to read from, and 1 partition can only be read by 1 consumer in that group. So let's say you have a topic, you're writing a lot of data, now you want to consume the data, you want to do it as fast as possible, so you want to find a way to horizontally scale. It's very straightforward to do it. What you want to do is you want to add more and more partitions to a topic. This increases how fast the write throughput, so you can write way faster and keep up to date because you have more partitions to write to. And then you arrange all your consumers in a consumer group, and then for every new partition you're adding, you add a new consumer to that consumer group. So in this case, you have 3 partitions, and your consumer group has 3 consumers. Let's say you want to scale it up because you're getting more and more writes. You can add 3 more partitions, A, B, C, and then you have, let's say, D, E, F. Now you have writing to 6 partitions. You want to add 3 more consumers, 4, 5, 6. Each of them are now gonna consume from, so D is gonna be consumed by 4, E is gonna be consumed by 5, and F is gonna be consumed by 6. So this way you have a dedicated consumer for each of the partition. So you're writing very fast because you have a bunch of partitions, and you're reading very fast too because each consumer is only responsible for 1 partition. So yeah, that's pretty much all I have for you. So we went through the basics of Kafka, and then we dug a bit deeper into how partitions work, how scaling up and down work, and how consumer groups work. So hopefully you found it very helpful. If you did, please leave a like and subscribe and comment any questions or concerns you have. And I'm gonna catch you guys in the next one. Bye-bye.